Okay, so this is your video for 6.3. This is the conditions for parallelograms. So yesterday, or for 6.2, you did the properties where I told you, hey, this is a parallelogram. So you said, well, then I can use these properties to tell you this about the parallelogram. So today we're going to be going backwards. I'm going to tell you information about the parallelogram or about the quadrilateral, the figure itself, and you're going to say, oh, then this is a parallelogram or it's not a parallelogram. Okay, so we're doing the same thing going backwards. So all those 5 properties from yesterday still will work for a parallelogram. Okay, so if I told you that, hey, here's this quadrilateral, the opposite sides are congruent, then you would say, oh, good, then it is a parallelogram. Okay? So in addition to those 5 properties of a parallelogram, you have one other thing, and it's called a condition instead of a property. It's not on your quad chart, and you may not write it on your quad chart. You have to remember this. So there's an extra bonus condition that's not a property. So in addition, you can tell the quadrilateral is a parallelogram if one pair of opposite sides are both congruent and parallel. So the property says, hey, if both sides are parallel, both pair of opposite sides are parallel, then you're congruent. Or if both pairs of opposite sides are congruent, then it's a parallelogram. So this new property says I only need one pair of opposite sides. But if I know about those one pair of opposite sides, I know they're both parallel and congruent, then that's enough. So let me show you. So if I don't know anything about these vertical side or vertical-ish sides over here, but about these horizontal sides, if I know that, hey, this side is congruent to this side and it's parallel to this side, then that's enough information to prove that this would be a parallelogram. So it's like a bonus property. Okay. All right, example 1. Show that JKLM is a parallelogram if A is equal to 3 and B is equal to 9. This is just as easy as it seems. All I'm going to do is plug in 3 and 9 and see what happens. So 15 times 3 minus 11 is 34. 10 times 3 plus 4 is also 34. So those two are congruent. 5 times 9 plus 6 is 51. 8 times 9 minus 21 is 51. Okay, so these two sides are also congruent. So now we write those same statements that we were writing yesterday, we just write them in reverse. Opposite sides are congruent, therefore it's a parallelogram. Nice and easy there. Okay, so determine if the quadrilateral must be a parallelogram. Justify your answer. Okay, so for A over here, I see that this is 107 and this is 107 and this angle is 73. So when I add right here, that adds up to 180. And when I add right here, that adds up to 180. So that means that consecutive angles are supplementary. Therefore, the figure is a parallelogram. Okay, if you could do, from 6.1 that all quadrilaterals have to add up to 360. So if I take 360 and I subtract 107 minus 73 minus 107 again, I would be left with 73. And then I could say, hey, look here, opposite angles are congruent, therefore it's a parallelogram. Either way you want to do it, you still get that it's a parallelogram. So you can use either property. For B, here I have one pair of opposite angles are congruent, but remember to be a parallelogram, it has to be both pairs of opposite angles. And this one does not show that, so it's not enough. Okay, both pair of opposite angles are not congruent. Okay, you guys try C and D and see if you can get that one. Okay, so for the first one, you have to do a little bit of work. So with this diagonal divides the parallelogram into two triangles. So that helps me because I know a lot about triangles. So I use third angles theorem to prove that these two blue ones are congruent. Remember, third angles theorem says if two angles from one triangle are congruent to two angles from another triangle, then the third angles have no choice but to be congruent. So then from here, I can just use opposite angles are congruent, so it's a parallelogram. These two were already congruent, so I just needed the other set. So when I add these two angles together, the blue one and the two arc marks equal a blue plus two arc marks, so together the whole angle will add up to be equal to one another. So there is opposite angles are congruent. It would be a little more work, but you could do, if you wanted to, because these angles are congruent, then these side you could use converse of alternate interior angles to prove that the vertical, semi-vertical lines are parallel. And then you could do the same thing going in this direction. Because these blue angles are congruent, then these lines must be parallel. So then you could do opposite sides are parallel, therefore it's a parallelogram. So multiple ways to do that, but whichever way is fine as long as you explain it. D is not true. In this one, the consecutive sides are congruent when it's supposed to be opposite sides. So this is actually a kite, which we will study about after when the new semester begins. Okay, so for the next example, we're going to throw a little bit of algebra in there. So we're still proving that these quadrilaterals are parallelograms, or we're deciding if they are, but we're doing it now on the coordinate plane. So that means we're going to use things like slope, midpoint, distance, those kind of things. And you can use any of the properties you want to prove that these are congruent. So I'm going to walk you through kind of several ways to do this, and you can pick your favorite, and whichever way you want to do it will always work. Okay? So I believe that the easiest way to do it is to use that new condition that says one pair of opposite sides is both congruent and parallel. So the reason I feel like this is the easiest is because I only have to work with one pair of sides. Any one of the other ones that you do, you're going to have to work with both pair of opposites. You're going to have to work with all four sides. So I just feel like the less points you have to work with, the better. It is totally up to you. So you can pick either pair. I'll just pick JK. So in order to prove that they are parallel, I will need to find the slope of JK. And if you want to put these on a grid, I definitely recommend you do that while you get used to it. I do think the more you get into this course that you should be able to find slope and find distance without having to graph everything, simply because that is finding slope, finding distance is going to be a concept you're going to need next year and the next year and the next year. So the better you get at it, the more it will help you in the long run to do it fast and easy. So JK, from -6 to -1, that means I went up 5. From -1 to -4, that means I went backwards 3 places. So we are at -5, 3 for the slope of JK. And then the opposite side of JK is ML. So from L to M, I went from 5 to 0, so I went down 5. And I went from 4 to 7, so I went over 3. So both of these have the same slope. Therefore, that pair of opposite sides is parallel. Same slope means that they're parallel. Actually, I don't really want to write in the middle of my workspace here. So let me write that down here. Same slope, therefore they're parallel. Now, the reason I found this way to be the easiest is because we've talked about before that slope and Pythagorean theorem, which is the same thing as distance formula, come from the same numbers. How far did I go up? How far did I go over? So as long as you're using your pre-simplified slope, which I didn't have to simplify any of these, so I don't even have to worry about that in this problem, you can use these numbers for your Pythagorean theorem. if I had done something like if I had 10 over 6 and I had simplified that to 5/3, I would have to use the 10 and the 6 for my distance formula. So just keep that in mind for the next problem. But for this particular problem, I didn't have to simplify my slope fraction, so I just use the same numbers as they are. And remember, we're doing distance, so negative direction, up or down, left or right, does not matter. So I just use 5 squared plus 3 squared. So 5 squared plus 3 squared is 34. 34 is 2 and 17. So that are both prime, so that doesn't break down. I just leave it as square root of 34. And look, I'm really not even having to do any work because these are the exact same slopes. So they will have the exact same answers. So I can say that these sides are congruent because their distances are equal. So then I can say, and how you justify your answer, I can say one pair of opposite sides is congruent and parallel. Therefore, this is a parallelogram. Okay, so all I did was I picked one pair of opposite sides, either side I wanted to, and I said, okay, let's find the slope. Okay, the slopes are the same, therefore they're parallel. Let's find the distances. Okay, the distances are the same, therefore they're congruent. So one pair of opposite sides is both parallel and congruent, therefore it's a parallelogram. Okay, some of my other students who don't like to do distance formula, they will just do the slopes of all four sides, and then they'll say, okay, these two slopes are the same, so these two sides are parallel. These two slopes are the same, so these two sides are parallel. Opposite sides are of both pair of opposite sides are parallel, so therefore it is a parallelogram. So if you like that way, you can do that way as well. The other way that I find, this is the same question, just new numbers. The other way I find to be easy is to prove that the diagonals bisect each other. Bisect means they cut each other in half. So they would be cutting each other in half at the midpoint. So if you can prove that the two different diagonals have the same midpoint, then you will prove the diagonals bisect each other and you'll prove it's a parallelogram. So again, you can always graph these on a coordinate grid if you want to make sure and that you're doing everything properly. You can do that. As time goes on, we'll try not to do that as much. So I'm going to start with A and C. So I have 2, 3, and 5, 0. So when I add those up, divide by 2, I get that their midpoint is at 7 halves, 3 halves. Remember, I'm doing the diagonal, so I want to do the ones across from each other. Now I want to go and do the same thing for B and D. So here we're at 6, 2, 1, 1, 7, 3. Looks familiar. Okay, so both of these diagonals have the same midpoint, which means that they would be bisecting each other. So this would have to be a parallelogram. So that's what I would say. I would say same midpoint. Means that the diagonals bisect each other. Therefore, it's a parallelogram. Okay, so that's also a pretty easy way to do that. I would make sure that you know how to do both ways because there could be a question, and actually this was the question where it said, hey, you have to do it using that condition. So if on a quiz or a test I tell you you have to use this condition up here, you need to make sure you know how to do that. But if I give you any choice you want to, then you can do all four slopes and say opposite sides are parallel, or you could do the midpoints and prove that the diagonals bisect each other. But just know both ways. Okay, last example here. The legs of a keyboard are connected by a bolt at their midpoint. So the bolt is here at E, and it is the midpoint of PR, and it's the midpoint of QS. which allows the tray to be raised or lowered. Why is PQRS always a parallelogram? Well, so if you draw in PQRS, then that what they just told us means the bolt is at the midpoint. So the diagonals are bisected, exactly what we just did in the last example. Therefore, this figure has to be a parallelogram. And since that bolt is fixed at that midpoint, even if I lower this tray, which means I'm kind of making PQ and RS, I'm making this angle get bigger so that the tray gets lower to the ground, it's still the same concept because that bolt is still set at the midpoint. So no matter how much I raise or lower this, it is still going to be the diagonals are still going to be bisected, so it's still going to be a parallelogram up or down or all around.